Snowflake Data Cloud explained how one platform is transforming modern data, warehousing, analytics, and AI. Hello and welcome. Today we are going to explore one of the most important platforms in modern data infrastructure, Snowflake. Over the last decade, organizations have experienced an explosion in the amount of data they generate and collect. Traditional databases and legacy data warehouses were never designed for this scale, diversity, and speed. Businesses now need platforms that can store massive data sets, process analytics quickly, support machine learning, and allow teams across the organization to collaborate on data securely. Snowflake emerged as a new approach to solving these challenges. In this video, we will break down what Snowflake is, why it became so widely adopted, how its architecture works, and why it is playing a critical role in the future of the data economy. To understand Snowflake, we first need to understand the problem it was created to solve. For many years, organizations relied on traditional relational databases or on-premise data warehouses. Systems like Oracle, Teradata, and SQL Server powered enterprise analytics. These systems worked well for structured data and predictable workloads, but as companies began collecting clickstream data, IoT data, application logs, and massive data sets from digital services, these systems began to struggle. Scaling them was expensive. Storage and compute resources were tightly coupled, which meant organizations had to scale everything together, even if only one resource was needed. Data pipelines became complicated and slow, and analytics teams often spent more time managing infrastructure than analyzing data. The rise of cloud computing opened a new possibility. Instead of running databases on physical hardware inside company data centers, organizations could run them on cloud infrastructure platforms like Amazon Web Services, Microsoft Azure, and Google Cloud. Early cloud data warehouses attempted to lift traditional architectures into the cloud, but they still carried many legacy limitations. Snowflake was designed differently. Founded in 2012 by Benoit Dageville, Thierry Cruance, and Marcin Zukowski, Snowflake was built from the ground up specifically for the cloud. Rather than adapting old database architectures, the company reimagined what a cloud-native data platform could look like. At its core, Snowflake is a cloud-based data platform that provides data warehousing, data lakes, data engineering, data sharing, and advanced analytics in a single managed service. It runs entirely on top of public cloud infrastructure but abstracts away most of the operational complexity. Users do not need to manage servers, storage provisioning, indexing, or performance tuning in the traditional sense. Instead, Snowflake focuses on enabling teams to store data, query it quickly using SQL, and scale workloads independently depending on demand. One of the most important innovations behind Snowflake is its architecture. Traditional databases tightly couple storage and compute resources. Snowflake separates them completely. Data is stored centrally in scalable cloud object storage, such as Amazon S3, Azure Blob Storage, or Google Cloud Storage. Compute resources, which Snowflake calls virtual warehouses, operate independently and process queries against that stored data. This separation allows organizations to scale storage and compute independently, reducing costs and improving performance. The concept of virtual warehouses is central to how Snowflake works. A virtual warehouse is essentially a cluster of compute resources that executes queries and data processing tasks. When users run SQL queries, load data, or perform transformations, the workload is processed by one of these warehouses. The key advantage is that multiple warehouses can operate simultaneously on the same underlying data without interfering with each other. For example, a data engineering team can run heavy transformation jobs while business analysts run dashboards and data scientists train models, all without creating performance bottlenecks. Another major capability of Snowflake is its support for semi-structured and unstructured data. Traditional data warehouses were designed primarily for structured relational data stored in tables, but modern applications generate data in formats like JSON, Avro, Parquet, and XML. Snowflake allows organizations to store and query these formats directly without complex transformations. This flexibility allows companies to ingest data quickly and analyze it using standard SQL queries. Snowflake also introduced an important concept called the data cloud. Instead of treating data as something that must always be moved between systems, Snowflake allows organizations to securely share data across accounts and even across companies. a company can publish a dataset and grant controlled access to partners, customers, or internal teams without copying the data. This capability reduces data duplication, improves governance, and enables entirely new business models where companies monetize datasets. Data sharing is particularly powerful in industries where collaboration is essential. For example, financial institutions may share market data with analytics partners. Healthcare organizations can collaborate on research datasets while maintaining security and compliance. Retailers can share supply chain data with logistics partners. Because Snowflake handles the infrastructure and access control, organizations can focus on deriving insights rather than managing data transfers. Another reason Snowflake gained rapid adoption is its ease of use. Many organizations already rely on SQL for analytics, and Snowflake provides a familiar SQL interface for querying data. At the same time, it integrates easily with modern data tools used for pipelines, business intelligence, and machine learning. Tools such as Tableau, Power BI, Looker, Apache Airflow, dbt, and many others connect directly to Snowflake. This allows organizations to build modern data stacks where Snowflake acts as the central platform for data storage and analytics. Performance is another key advantage of Snowflake. Because compute resources can scale independently, organizations can allocate larger virtual warehouses for demanding workloads and smaller ones for routine queries. Snowflake also supports automatic scaling and concurrency handling, meaning multiple users can run queries simultaneously without slowing each other down. This elasticity allows teams to maintain performance during peak demand without permanently paying for oversized infrastructure. Snowflake also includes strong data governance and security features. Organizations can implement role-based access control to determine who can view or modify specific datasets. Data encryption is applied both at rest and in transit. Snowflake also supports features like secure views, data masking, and auditing capabilities to help organizations comply with regulatory frameworks such as GDPR, HIPAA, and other industry requirements. As data becomes more sensitive and regulated, these governance capabilities are essential. In recent years, Snowflake has expanded beyond traditional analytics into data engineering and machine learning workflows. Features such as Snowpark allow developers to write data processing logic using languages like Python, Java, and Scala while executing the computations directly within Snowflake's compute environment. This reduces the need to move data into external processing engines. Snowflake also supports integrations with machine learning frameworks and data science environments. Another area where Snowflake has expanded rapidly is support for data applications. Organizations increasingly want to build applications that run directly on top of their data platforms. Snowflake introduced the Native Application Framework and Snowflake Marketplace to enable developers and companies to build and distribute data applications within the Snowflake ecosystem. This allows software providers to deliver analytics, tools, data services, and models directly to customers through the platform. The Snowflake Marketplace represents an emerging data economy where companies can share, exchange, or monetize datasets. Businesses can publish curated datasets such as financial market data, demographic information, weather data, and retail trends. Customers can subscribe to these datasets and immediately analyze them inside their Snowflake environment without building complex pipelines. This model reduces friction and accelerates innovation across industries. Despite its strengths, Snowflake is not without challenges. Because it is a fully managed cloud service, organizations must carefully manage usage to control costs. Queries, compute resources, and data storage all contribute to the overall cost model. Companies that do not optimize workloads may see higher than expected bills. In addition, Snowflake operates primarily within public cloud ecosystems, which means organizations must consider cloud governance and multi-cloud strategies. Looking ahead, the role of platforms like Snowflake is expanding as artificial intelligence and real-time analytics become central to business operations. AI models depend on high-quality, well-governed data. Data platforms must support large-scale pipelines, feature engineering, and model deployment workflows. Snowflake is investing heavily in AI integrations, data collaboration capabilities, and developer platforms that allow organizations to build intelligent, data-driven applications directly within the data cloud. The broader trend behind Snowflake's success is the transformation of data into a strategic asset. In the past, data infrastructure was primarily a back office function. Today, it drives product innovation, customer insights, operational efficiency, and competitive advantage. Companies that can centralize, analyze, and share data effectively gain significant strategic benefits. Platforms like Snowflake simplify this process by providing a scalable foundation for modern analytics. As organizations continue their digital transformation journeys, the importance of cloud-native data platforms will only grow. Snowflake represents a major shift from traditional database thinking toward a flexible, collaborative data ecosystem built for the cloud era. Whether used for analytics, machine learning, data sharing, or building data-driven applications, Snowflake has become a cornerstone technology in the modern data stack. Thank you for watching, and I hope this overview helped you understand how Snowflake is transforming the way organizations manage and unlock the value of their data.